Hello, welcome. Let's try to solve another Leetcode problem. 1223 dice roll simulation. So for this problem, we are going to simulate a dice roll. So this n going to be equal to 2. It means we're going to have 2 rolls, and we are also getting a roll max. So this means for each of the dice. So for example, for the value, if it is 1, we cannot have more than one contiguous ones. So it means we cannot have a 1 1, or we cannot have a 2 2. Yeah, we cannot have like more than one contiguous ones, or we cannot have more than one contiguous twos. So this means in total there are going to be 36 different cases if we roll it 2 times, but we need to minus this 1 1 and minus this 2 2. So finally it's going to be 34. Yeah. So how can we solve the problem? We can check that if we are given 10 to the power of 9 plus 7, definitely this is going to be a dynamic programming problem. Now we just need to find the state for our DFS. So if we are going to use a DFS, definitely we need to find the state, and we can use index I. It's going to be the number of rows. So I gonna be starting from 0. Yeah, and then we also need to remember what is the last value for the dice. So it can be 1 to 6. Yeah, this last is used to calculate how many contiguous ones or how many contiguous twos. So now we still need to have another value. It means the count. Yeah, so this means for the DFS, we're going to have 3 values. This I going to be starting from 0, and this last, it means the last row of the dice. It can be 1 to 6. So for example, if it is a 2, and this count is just used to remember how many twos. So for example, it can be 2 twos or it can be 6 twos, it doesn't matter. Yeah. Now we just need to check what is going to be the maximum value. So it's going to be 15. So it means the count gonna be 15. So this count gonna be 15, and the last value gonna be 6 because it is 1 to 6, and this I gonna be 5,000. So if we can design such kind of a DFS and with a case, definitely we can solve the problem, because this gonna be 90 times 5,000. So what's gonna be the final result? Yeah, so it's gonna be 4.5 times 10 to the power of 5. So this is exactly designed for dynamic programming. So this means we can solve it. Yeah, we only need to prepare 3 variables. What's going to be the index I? It's going to be start from the beginning. It's going to start from 0, or you can start from value n. It doesn't matter. Or you can. So for the last, it means the last index. It can be 1 to 6, and for the count maximum, it can be 15. Yeah. Now let's just use this kind of idea to solve the problem. So I'm gonna prepare a case, and I'm gonna define the DFS. It's gonna be I, last value, and the count. So let me do some preparations. So for the mod, I'm gonna prepare a mod. It's gonna be 10 to the power of 9 plus 7, and yeah, I think I can directly call the DFS. So I'm gonna return the DFS with 0. So the last value, normally I'm gonna set a -1. It means -1 is not equal to 1 to 6, and the count is going to be starting from 0. Now what are we going to do? We're going to check this index I. If this I equal to n, definitely there's one case, so we're going to return a 1. So otherwise we're going to check the different values. So for j in range for each of the for each row of the dice, so it's going to be starting from 1 to 7. Yeah. Now there are 2 cases. So this is our current value. It's going to be j. J can be equal to the last, or j can not be equal to the last. So we just check in 2 different cases. So if j are not equal to the last, yeah. So this means we're gonna prepare a result. So this result is gonna be start from 0. Yeah, so this result gonna plus DFS with I plus 1. It's gonna be the next row, and currently this last gonna be j, and the count gonna be 1, because this count it's not equal to the last value. So currently, this count is to check how many contiguous values. So the meaning of the count is contiguous values. Yeah. So this is the meaning of the count. Last is just for the last value, the last dice value. Yeah. And this index I is just the number of rows from 1 to 5,000 maybe. And this is for one case if it is not equal to the last, but if it is equal, so the result is going to plus equal to I plus 1 for the next row, and the previous value going to be j, and the count going to be, we're going to update the count, going to be plus equal to 1. Yeah. But if this is j equal to the last, we have to check, because we didn't use this information, row max, we have to check if it is less than the row max, and then we can go for the DFS, otherwise we cannot. So this means from here, we're going to check. So elif, so j equal to the last, so this means j equal to the last, but we also need to check the count. So the count should be less than the row max with this j minus 1. Because for this row max, the index is actually starting from 0, but this 0 just means the dice value of 1. So this means we need to use this is j minus 1, so this means the first value is going to be 1. Yeah. I think that's all about it. Let me just run it to have a check if it works. Because I didn't have a return, I needed to return a result. And let me modular mod. Let me just check. Yeah, now as you can see, it works. Now let me just submit it. Yeah, as you can see, it works, and the speed is okay. It is just 1 second. And how can we approach such kind of problem? I mean, definitely there are many ways. We can start from 0 minus 1 0, or we can start from this n. But that is not important. I mean, the coding is not important. The important is that we can understand the problem according to the information of the problem. So we are giving a dice simulation. So for each row, it's going to be starting from 1 to 6, and we are also giving a row max, and we need to understand what is going to be the meaning of the row max. It is a contiguous value, consecutive times. It is not this one or that one, it is consecutive ones. So this means for the first row it is a 1, for the second row it is another 1, so this means it is going to be consecutive ones, and you have to understand it like that. And if we are giving a 10 to the power of 9 plus 7, normally this is going to be the dynamic programming. If it is not dynamic programming, it must be mathematics, combinations, or others. Yeah, definitely we cannot use 10 to the power of 9 plus 7 times complexity to solve the problem. We have to use a dynamic programming. So if we understand the problem, the next step is that how can we define the state of the dynamic programming? So we're going to start from this index I, it's going to be the first row. And then we also need to remember what's going to be the last value for the dice. And we also need to have a counter of how many values of this last. Yeah. If we can find this kind of definition, normally the problem is going to become easier. We just need to find two cases, if it is equal to the last or not equal to the last. And we just needed to use this information to solve the problem. Yeah, I think that's all about it. Thank you for watching. See you next time.